Today, we're going to be taking a look at this ErikHill ER02 EMF tester that they sent me for review. As a radio enthusiast, I thought this would be kind of a fun and unique gadget to kind of take a look at and see if it had any practical application for ham radio or electronics enthusiasts. So before I get on with the review, I just want to mention quickly that this video is being offered up for entertainment purposes only and is not intended to take the place of the manual or other documentation supplied by the manufacturer. So make sure you read through that before you use this unit. So inside the box we have a short USB mini charging cable, the manual, the unit itself, and this little yellow piece, which is really just part of the packaging. It just kind of fell out when I opened everything up. The main screen is here, of course. Control buttons are all located here. And on the bottom of the unit is a USB mini charging port. So to power the device on, I just push the power button and everything boots up and comes on. The mode button directly below the power button allows us to change the mode of the tester. Right now you can see from the screen up here, it's in RF mode. If I push the button once, it cycles into electric field mode. Pressing it again cycles it into magnetic mode. And then if I press it one more time, we're back to RF mode. The button over here toggles between average reading and max reading, and that's indicated by this field up here on the screen. You can see I've just pushed the button and we're back to max. Push it again and we're back on average. The button over here labeled sound obviously toggles the sound on and off. And when the sound is on, you can see a little speaker icon on the screen up here. The button over here is used to change the measurements of the magnetic field readings between milligauss and microteslas. Right now it's in milligauss mode. If I change it to microtesla, you can see the display changes and the reading will change as well. And we'll look at that a little bit later. And then the last button, the graph button, toggles between sort of a fuel gauge type display with a main measurement up here and a peak down here. And then if I press it, it changes it into sort of a bar graph mode with the measurement up here and then a bar graph along the bottom. To change the brightness of the display, I just have to push and hold the milligauss button. And you can see it dims it. If I push and hold it again, it toggles up to bright. Short pressing the power button puts it into hold mode. You can see that indicated up here on the screen. Another short press takes it off. Long pressing the graph button changes the display from light theme to dark theme. In electric field and magnetic field measuring mode, the unit can be zeroed out. In order to use it, I'll long press the sound button until 0 cal shows on the screen, and then just push the power button, and you can see it zeroes it out. Now one thing to note is once you've power cycled the device, it kind of goes back to its default calibration, and you'll have to kind of re-zero it again if you're in sort of a noisy environment. One thing to keep in mind about this meter is that it is not intended, I don't think, to be sort of a exact measuring device. It'll give you a good indication of whether or not there's an electromagnetic field or an RF field present and kind of a relative idea of how strong it is, but I don't think it's intended to be used to take accurate lab-style measurements. So keep that in mind if you're considering purchasing one of these. For my first test, I've got an old Astron 12-volt DC power supply here, and I've currently got it turned on. I've got the meter in electric field mode, and you can see that we're measuring a very low electric field. If I move this around here a little bit, you can see not too much happens until I get over here, sort of back by where the power cord comes into the back of the power supply. Now, as you can see in here, as I get closer to the power cord back here, the meter starts to register a higher electric field. If I bring this back to the front and switch over to the electric field mode, you can see we're getting a pretty high magnetic field from the transformer inside the power supply. If I shut it off, you can see that drops right down to 0. Turn it back on, and there's that magnetic field again. Now if we switch over to RF mode, you can see we're getting very little RF energy right now, and that's probably just background from the room. If I turn the power supply off, you can see that the RF energy really doesn't change a whole lot. For the next test, I have this cheap camera ring light. It's not even turned on at the moment, it's just plugged into its USB power supply in the wall. And if I bring this over so it's close to the measuring head, you can see the electric field goes way up to 380, almost 400 there, depending on kind of where I move it. Now, if I turn it on, I'll try to keep it faced away so you guys aren't blinded. Let's see, does it really go up too much? Nah, it stays about the same even with the light on. So just to demonstrate graph mode, I've switched over. You can kind of see what happens as I bring the light close to the measuring head. If I bring it back down, the graph goes down. So now I'm over in magnetic mode with the micro Tesla measuring scale set. The light is off, and if I move it around, we're really not seeing any magnetic field. If I turn it on and bring it close, still no magnetic field. So now, interestingly enough, if I switch the meter over to magnetic mode and bring the light over, you can see we kind of stay at 0 until I move this can of deoxit out of the way. And then if we bring the light over, the meter goes up and starts to register a magnetic field. So this metal can is sort of sinking that magnetic field and kind of throwing things off a bit with the measurement. Now if I switch over to RF mode and bring the light over, we don't really get any kind of RF field coming from this light, which I guess is a good thing. One thing to mention about the magnetic field measuring in this unit is that it can only measure what I'll call dynamic magnetic fields. You can see if I have a static magnet here and bring it up to the unit, it'll kind of measure a little bit of a magnetic field as I kind of move it around past the unit. But if I kind of just set it here and leave it stationary, once it stops moving, the measurement goes back to 0. So what that means is that if you're looking for sort of static or maybe DC magnetic fields, you'll have to keep the meter moving in order for those fields to register. If you're looking at magnetic fields caused by alternating current electrical flow, then you won't have to move the meter because the magnetic field is constantly changing while the electricity is flowing. For the next test, I wanted to check the meter underneath some high tension power lines. Hopefully you can see them kind of above and behind me there. So I've got the meter set to the electric field, and I've got the measuring face up, facing towards the power lines, and you can kind of see there what we're getting for a reading. Now depending on where I kind of move around and hold the meter, the reading can kind of jump kind of up and down, which is, I guess, what you would expect. Here's what we get on the magnetic field set to the micro Tesla measuring scale. And if I switch over to milligauss, there's the measurement there. And if I switch over to RF mode, well, we're not getting a whole lot there, which is, I guess, what we would expect. Now, I'm not real sure what the voltage is on these high tension lines, but I do know that it's significantly above what the street voltage is, but maybe not as much as those high tension lines that you'd see on the really big towers. Another thing I can check with the meter is to see how much of an indication we're getting of RF energy from my ham radio antenna, which is over there on the opposite corner. I'm using an ICOM 2730 dual band radio. I've got it tuned to the 2 meter frequency of 146520. I'll key it up at 50 watts with the meter here just on my dashboard, and we'll see what we get. That was 2 meters. Now let's test the 70 centimeter frequency and see what we get. Interestingly enough, on 2 meters, the reading was fairly low, but on 70 centimeters, it was a lot higher. And that's about what I'd expect for a couple of reasons. The first being that as you go higher in frequency, there's more energy kind of being produced at those frequencies. Another reason that that makes sense is because the antenna inside this unit is going to be fairly small to fit inside the box. So it's going to be more efficient at 440 megahertz than it is at 146. As I said at the beginning of the video, this is not a device that you would use to take accurate measurements. It'll give you a good idea if an EMF or an RF field is present and a relative idea of how strong it is, but I don't know that it's super accurate in its measuring ability. Having said that, this may be a handy gadget to have in your ham shack if you want to get a relative idea of how strong the RF and EMF fields are in your shack, but don't want to spend a lot of money for a lab grade piece of equipment.